stay on time and honor all of our speakers most of the time. It's always hard to kick your PhD advisor off the podium, right? So our next speaker is Ed Camp. How about it? You heard Michael, I'm not saying doctors, I don't know.
Thank you, Judith. Thank you guys for coming to this talk. I want to thank my co-authors as well as the University of Florida and the National Academy's Gulf Research Program for funding this work and supporting it. So where are our stakeholders right now? It is funny to call stakeholders ours, but we will continue with this. Answering this question would require understanding perhaps who our stakeholders are. Are these people who live in the counties or the states or even larger areas in which we work? Are they people who live elsewhere but fish in these areas? Are they people who have to live and fish in these areas? How we define these stakeholders and where they travel from to fish in the specific locations where we work has, I think, something to do with how these areas are managed, particularly as they move forward towards spatially explicit or place-based management, and that's what this talk is about. Backing up for a second, recreational fisheries, I'm focusing here on recreational fisheries, not commercial fisheries. These fisheries are often described as socioecological systems, which sounds fancy, but it is simply a recognition that the outcomes of the system depend on often feedbacks between fish populations and fishers that affect each other. In reality, however, these systems are most likely even more complex. We have different biological or environmental elements in the specific locations where a fishery is. There's social, cultural, historical context to different places, and together these things are overlaid with jurisdictional and sometimes politically motivated boundaries, like county lines or state lines, that may have nothing at all to do with the resources or the users. So all of the spatial contexts, I believe, can affect the governance that is exerted on these fisheries, whether that's in terms of how those approaches are made, which stakeholders are considered when we're planning something, or the actual actions and how they're implemented. Increasingly, this challenge of spatial socioecological systems is addressed with something called place-based management. I will not read this quote, you are welcome to. I find most definitions of place-based approaches to be somewhat amorphous, and I think of it more of a continuum between, on the one hand, on the traditional side, we have perhaps single species, top-down, and very large spatial scales, so entire regulations set by a management agency at the state scale. And on the other hand, we might have more bottom-up stakeholder-led, multi-species, smaller spatial scales. For example, some of the work that I was just talking about, looking at bays or estuaries. There's obviously challenges with a place-based approach, and for a long time, one of the big ones that we thought about was, well, what spatial scale regulates the fish populations? How do they move? How is their recruitment set? And those things are real, but an element that we have perhaps spent much less time thinking about is what are the spatial dynamics of anglers themselves? Where do they travel from? What is the angler home range? While these travel data might be used for some economic analysis, it was really difficult for me to find any evaluations of these in the literature. I think they're important, though. They're important, obviously, for identifying who the stakeholders are in a particular area that we're concerned about and trying to draw the boundaries. If we're looking at a smaller spatial area for management, it might be interesting if we're trying to engage the stakeholders. Where do we set the meetings up for the workshop? Should they be right near the water if most of our anglers are coming from more inland counties? And they're also useful for understanding, I think, more traditional management approaches. Where anglers travel to and from has a lot to do with how dollars are redistributed. This would be called economic impact or market activity, and this is directly related to jobs. And finally, that can have some implications for standard management if we have local perturbations in the fishery, whether that's a cold kill or a red tide event. How will anglers redistribute through space to fish other areas when something has happened? And finally, are these spatial travel elements of an angler, are they different between species or across regions? So this work was intending to inform potential spatial or place-based approaches if Florida chooses to go that route in the future by looking at a statistical evaluation of angler travel dynamics in Florida. We looked at different regions of the state, north and south, and a few different species. And we did different analyses. We did statistical analyses, which we'll talk about in a minute, and then we did some descriptive analyses, we made pre-maps. And we looked at North Florida, which is roughly Tampa and up, and in South Florida was the opposite. And 6 species we examined: red drum, common snook, spotted sea trout. These are inshore species, so we looked at people who were targeting these species inshore. 2 of the main reef species, gag and red snapper, and then the glorious Atlantic tarpon. And I should point out these illustrations are by Diane Peebles, who's done, I believe, for FWC, the state agency here in Florida. I looked at 4 metrics on the statistical analysis. First one is called statistical expectation. This is basically, it would be the mean if the data were normally distributed, because the data are generally not normally distributed in travel distances because you can't travel a negative distance. I have to say statistical expectation, but you can think in your mind it is the central tendency of these data. The median, the standard deviation, quantiles, and the descriptive approach was to make a map, which is pretty self-explanatory. The data themselves come from the National Marine Fisheries Service, MRIP, Marine Recreation Information Program, not to be confused with MREP, which is unfortunate in my opinion. Anyway, they send people out to intercept anglers near their fishing sites, whether they're fishing from shore or boat, and they interview them and they get information about what species were they targeting. That's how we know what they were fishing for. Their home county of residence and the intercept coordinates where they talk to them. And from that home county, we can grab the centroid of that county weighted by population and calculate the Haversine distance, straight line accounting for curvature, and then look at the statistics of those distances, and most of these were log normally distributed. So results. These are small. I'm going to blow up on this in a second, so I'll just walk you through this, so do not worry here. This is statistical expectation, median, standard deviation, quantiles of data. X-axis are distance, one-way distances. Y-axis are the different species. Atlantic tarpon and red snapper are the first 2 lines, so people are traveling very far here. Gag and spotted sea trout are the second, so farther, but not as far. And then red drum and common snook are the closest. A couple things to point out here before I zoom in on this more is that you might look at this, at the statistical expectation and say, well, red snapper and Atlantic tarpon are both very far. But if you look at the median and the 50% quantile, which are these dots here in the quantiles of data, the lines are 95% confidence intervals, the dots are the point estimates. What you see is that most tarpon trips, the median tarpon trip distance one way is 80 kilometers, but it's actually much larger for red snapper, about 125 kilometers. And then the 50% quantile, again, for red snapper is much higher than it is for Atlantic tarpon. What this is showing you is if you imagine the distributions, basically most of the trips targeting tarpon are a short distance, but there's enough long distances that it drags that statistical expectation out. Conversely, for the snapper, most of the trips are quite a long way. So the statistical expectation is similar, but actually they're two different things. Okay, blowing up on the statistical expectation and looking at North versus South Florida. North is in black and South Florida is in gray. And I put this in here because we see this little flip-flop with these 2 species that people travel for. Atlantic tarpon, people don't travel very far in the north. They do travel very far in the south, and it's the complete opposite with red snapper. Generally, we see greater distances for gag and spotted sea trout in the north than I might hypothesize, but I do not know that could perhaps be owing to the fact that Florida is a peninsula, and there's only so far one can travel in the peninsula part of it. One of the things I was surprised at was that the spotted sea trout distances were greater than the common snook or red drum. I perhaps have not given spotted sea trout their due. I do not consider them a glamorous species, whereas I am quite enamored with the red drum and common snook, but many people travel very far for spotted sea trout, so this was unexpected to me, perhaps not to others. And that's it for the statistical explanation, so on to the pre-maps. This, as you will see, is red drum. We just drew lines from where the people started to where they wound up. You can't really see them, those little pink dots that look like invasive snail eggs along the coastline of Florida. Those are the intercept locations. The width of the line and the warmth of the color, so red, represents the number of trips. So right where we are, there's a lot of fishing effort from the counties surrounding Tampa Bay to locations in Tampa Bay. That makes sense. A lot of people from the Orlando area heading over to the Indian River Mosquito Lagoon. You have Jacksonville, that's Gainesville going to Cedar Key, Ocala going towards Crystal River, and so forth. So it makes sense. Common snook, as we would expect, is mostly in the southern part of the state. That's because they don't live very often in the north. although perhaps that's changing. And spotted sea trout. I want to toggle back real quick. So this is red drum. Look at the panhandle up here. And this is spotted sea trout. So very similar to red drum, with the exception that a lot more trips are coming from North Florida, South Georgia, and South Alabama. So this is where that statistical expectation for sea trout really got pushed over to the right, greater distances. A lot of people coming out of state to target these fish, surprisingly. Gag grouper, as makes sense, it's a Gulf species primarily and mostly in the north. And then red snapper, which is really fascinating to me. So there's a little bit of red here. This is, I think, Pensacola from local people traveling short distances. These are all people out of state that are traveling to these ports on the panhandle, and that's quite interesting. You see where that distance comes from. And then finally, Atlantic tarpon, as might be predicted, we have Tampa, we have the Sarasota down to Boca Grande, and we have the Keys, people coming from all over to fish for this species. So I find these maps fun. Then there's a couple of ways that I think they can be important for stakeholder engagement. One of them is, as I've mentioned before, where we have the workshop meetings. When you look at those maps, it might make sense that if you're concerned with Indian River Mosquito Lagoon, perhaps some of those workshops push closer towards Orlando if a lot of the people are actually coming from there. Oh, we have water. Another way would be interpretation of the meeting results. So if you actually can ask the people at a meeting, what zip code or county are you from, you can understand, are the opinions you heard at that meeting descriptive of the entire spatial range of anglers, or are they more specific to those people who were very close to where you had the meeting? And finally, potentially these maps or the statistical expectations could be used as engagement tools to explain to stakeholders or even local business owners, hey, here's where a lot of your trips are coming from. It's money in the county or it's out of the county. As you step up to place-based approaches, one of the important things that I would take away from this is that not all species perhaps would be as easy to go with a place-based approach. And ideally, place-based approach would look across species, but baby steps. So I think red drum and common snook would be a good place to start. These had the shortest travel distances. Generally, there are people who are fishing for them live very close to the resource, and that makes the logistics of setting up meetings or workshops perhaps easier. There's also some evidence from literature, I believe Gutierrez, suggesting that willingness to engage in management leading up to co-management is positively correlated with proximity, living to the resource. And finally, there's the idea of sense of place, which is actually a really, really broad topic in natural resources, quite multidisciplinary. But basically, it's the idea, it's the cognitions that humans have about a specific place, and with respect to recreation, it might be encompassing things like their attachment to a place, a fishing spot that they like, or what that place means to them. And one of the themes in sense of place is resident versus visitor. And in this case, we see often that attachment of a site, so the importance of a site might be similarly important to people, whether they live there or coming to it, but the meanings that they have for it would be different. Why I think this matters is it's possible that we look at some places where we have a lot of conflict, like Boca Grande, and it may be able to pull that apart by looking at local versus non-local people and wondering whether the meanings that they have for that place actually differs. And then finally, the implications for traditional management include this market activity. When we have trips, we're redistributing dollars across county lines or some cases state lines, and that's quite important for the panhandle of Florida, where you're bringing a lot of dollars into these local coastal human communities from out of state. And finally, from looking at this, we might begin to make some assumptions about how effort would redistribute. I often build population models of fish and fisheries, and one of the really tricky things with that is trying to predict what will happen if we do something like put in an artificial reef, or we stop fish, or there's a fishery closure. And having an understanding of how far people generally travel to go fishing gives us sort of a first take on this, on what we would do with the redistributions. Moving forward, I think a couple of things that we can do here is, first, we can expand or subset this to meet needs. For any coast that has MRIP data, so any of the coastal states in the country, for any species, we can make these maps almost instantly, which I think is fun. And so if you want a map, come talk to me. I'd love to work with you on those things. In addition, I think that there are some novel, if somewhat crude, socioeconomic analyses that we may take using these travel distances and sort of traditional travel cost methodologies to try to put a value on species-specific fisheries, at least in a crude manner. And in addition to that, I'm hoping that this work leads us one step closer to at least being able to better explore what's possible and what's likely with place-based approaches on the marine side here in Florida. So with that, I thank you for listening. I will take questions or comments if you have any.
Any questions? Oh.
Sure.
Did you standardize the travel distances? So you shot these, excuse me, the expectation, the differences in travel distances. Did you standardize them in some way to like the number of fishers, or like you said, there was a difference between north-south and thinking like standardizing to travel distance versus like miles of available coastline to fish? Like, did you standardize it at all in some way, or is it just the distance they travel?
The short answer is it's just the distance. I'm not sure I'm understanding exactly what you're getting at with the standardizing.
Just, I'm just thinking like the distance traveled, I feel like is just a first kind of big number, but that might, if you have an uneven sample size of fishers, for instance, or, they're traveling further, but they have more available coastline, say in, the south versus the north, because they're, right, you're on the peninsular side as opposed to the panhandle side. So the distance traveled potentially might be different if you factor in, if you're living in Orlando, you have two coasts to choose from, whereas if you're living in Georgia, you don't have quite as much coastline to choose from potentially. Does that make sense? So I'm just wondering if you were to factor something like that in and standardize it in a different way, like landings versus CQE, if you were to like standardize it in some way, if you would get a different result or different numbers.
Okay, I think
Does that make sense?
I think I understand what you're saying,
I mean,
and I want to.
chat about it with you.
Sure, I'll make one quick comment on it because it's really important that what I've explored here is exclusively, as you said, just the raw travel distances. It's looking at how far did people actually travel from where to fish, and that ought not to be confused with squeezing inference from a revealed choice from multiple alternative choices to get at the relative preference or value that people place on one thing versus another. So the latter would be, if I look at where someone traveled from and where they went, that is essentially the logic behind site choice models. And so then I can say, well, here's their given choice, and here are the attributes of the choice they made and their alternative choices, and now I can estimate the part worth utilities associated with each of those different attributes. And that's the logic which you may be well familiar with behind a lot of the site choice models that economists use. I did none of that here. The data can be used for that, but it would require a very different setup than what I did. But these same data are the input that people have used in their ROMs or their random utility models in different cases.
That's what I'm thinking of.
Yeah.
Thank you.
Yeah.
Anybody else?
So I lived in North Florida, and now I've lived for 20 years in Southwest Florida. And one of the observations I made was in North Florida, particularly someplace like Mississippi, Pensacola, the Panhandle, if you look at the inshore fishes, spotted sea trout is one of the only ones available. There's red drum too, but spotted sea trout is close to land, and guys that come down with their small boats are out of our research site in North Florida. People were traveling down from Albany. That was the major population of the Yukon Feeder River fishing.